Hi everyone. Can you see my screen?
Yes.
Yeah. Okay. Okay. So let's begin. Okay. Hi everyone. My name is Haoliang Li, and nice to see you in this virtual workshop. So in this session, I'd like to share with you some of my research works about the trustworthiness, robustness, and the fair AI systems, which can be applied in the smart cities. So before I start, I want to give a brief introduction of myself. Yeah, I just joined the CityU department last month as an assistant professor. And my research background is more related, mostly related to the research themes of the big data, machine learning, and also artificial intelligence. But also my works are also related with the computer engineering as well as the signals and image processing. Okay, so now with the development of the machine learning techniques and also the deep learning techniques, and also the popularities of the social networks and our networkings, where we can get a lot of data from multiple modalities, we can achieve the very desired performance, right, by using deep learning technologies on different kinds of applications like the autonomous driving, fintech, elderly care, and VR AR application. But despite the success we have achieved so far, we suffer from the reliability problems of the deep learning, our AI techniques from different perspectives. So here I want to show you one example. So for example, the face recognition system, right? Like we can achieve like nearly 99.9% accuracies like few years ago, but it's known that our face recognition system is very vulnerable to the spoofing attack, where an attacker can use some special medium like the printed paper or replay videos, right, to replay a genuine user's face in front of our cameras to bypass the face recognition system, which we refer as the face presentation attack. So for another example, we have also witnessed a lot of success of the autonomous driving, right? So where we can have the AI system powered by, based on the visual data, right, to recognize the traffic sign, right? So, but recently, the researcher also found that this kind of system is also vulnerable to the adversarial sample attack, even in our real world, right? Because the attacker can simply print out the adversarial samples and stick onto the traffic board to further fool the AI system. So, well, yes, there are many reasons why it leads to this kind of security and trustworthiness issue. But I think one main reason is that despite the fact that our deep learning system works very well, we have no idea why this works, right? How does this kind of decision makes, right? So, yeah, so I think the trustworthiness issue, especially related with the explainability and also how can we defend different kinds of possible attacks is very important, right? To make our AI system to be deployed in our real world. But on the other hand, our AI system is also very vulnerable to the so-called corrupted data or the data from another environment. So for example, recent research works found that, right? So if our testing data is corrupted with different kinds of noise, so these kinds of noise like can be due to the camera noise, like the shot noise, and also because of the environment, like the fog, and also the lighting conditions, and also because of the transmission issues, right? We have the compression related with the H.265, this kind of coding standard, right? So if the testing data are corrupted with this kind of noise, we also observe that the AI system can fail in these cases. And also because one cannot collect the data in all possible conditions. So here I give you one example for autonomous driving. If we train AI systems for autonomous driving, like in Hong Kong, so we want to ask whether it can be applied in Singapore. Actually, the researcher found that the performance is actually very poor. So how we deal with this robustness issue, yeah, related with both the natural corruption as well as this kind of domain shift is also important, yeah, to make our AI system to be deployed in our real world challenges. And last but not the least, okay, so we also have the fairness issues of the AI, right? So here is an examples of the pedestrian detection, right? So pedestrian detection is also quite important for autonomous driving, right? Because we have to, yeah, to make our driving system safe. But in most of the cases, right? So in our database, which are publicly available, we see the humans are, yeah, they are either like riding a bicycles or they are walking, right? So we want to see that if a disabled pedestrian, okay, so whether our AI system can detect these kind of peoples or not, because a good AI system has to be fair to all peoples, no matter the race, whether they are able or disabled, right? So this issue is also important. But in many cases, like in our AI algorithms for the public available database, we face these kinds of long tail problems, right? Which means that for some cases, for some categories, we are only able to collect only few data. So which means that our system may not be fair to these types of categories, right? Because our models can be biased, yeah, with the majority groups, right? So yeah, my research work is mainly focusing on the AI reliabilities, right? During my PhD study as well as my postdoc studies, I focus on this kind of issue. For trustworthiness, I mainly focus on the security issues. There can be a lot of trustworthiness, like explainabilities, and also like the human-computer interaction. And so I mainly focus on the security. Particularly, I focus on the face recognition systems to prevent the AI systems from malicious attack. As for the robustness issues, I mainly focus on this kind of the cross-domain scenarios, which I just mentioned. Like, okay, what if I train AI models on dataset A? Can we apply it on B, C, and even unseen dataset, right? So last but not the least, the fairness issue. Yeah, at this stage, I don't have any papers, but I think the fairness issue is also highly related with the trustworthiness and the robustness. Well, I have to say these three concepts actually, they have a lot of things overlap, right? Yeah, but all these three things together can make our AI system more reliable, and which we aim to be applied to apply these AI systems in our real world. So besides the AI reliability itself, I'm also interested in other research works which are also related with the AI reliabilities. So one example is that the fundamental machine learning research. Yeah, particularly I'm interested in the kernel main embedding. Yeah, kernel main embedding is I think is an elegant concept in the statistics, but recently researchers found that such concepts can also be applied in machine learning research, particularly the transfer learning, yeah, domain adaptation and domain generalization research. Right. So besides the fundamental machine learning research, I'm also interested in the application of the AIs. So one example is the computational photography, so which I think is highly related with the robustness issue, because in practice, yeah, we want to apply the computational photography perhaps as a data pre-processing stage, right? To make our training and testing data, yeah, more robust to different kinds of corruptions, right? And besides that, I am also interested in this kind of software and system engineering part, so which I think is very important to deploy our AI in our real world, right? Because just now, the research works I mentioned are all based on the algorithm levels, but in practice, we have to apply the algorithms, right, into a system for deployment issues, right? So I think this is also quite important. So last but not the least, yeah, here are some boasts. Yeah, but what I want to mention is that what I really believe that is that the dominant measurement of my success is actually the success of my students. So which means that I will try my best help the students, right, to achieve your dreams, yeah, no matter in academics or in industry, right? Okay, so I think that's all about it. Thank you very much.
So for the student, do you have any questions for Haoliang? So maybe I can ask one question for the students. So Haoliang, what's your expectation for your new PhD students?
Well, actually, it really depends. For my research, right, because I have background in both the fundamental research as well as the application research. So I think for different students, if they have different research interests, so the requirement can be different. So if you are interested in the fundamental research, machine learning research, so perhaps mathematics is quite important because yeah, the kernel main embedding, we have to deal with a lot of statistics things, right? But for the application, especially related with the not only the AI application, but also like the software or system engineering. So I think the coding is quite important. Yeah. So I think this, yeah, is my expectation.
Thank you very much. I think it is very clear for the students.
Okay,
and
thank you.
Yeah, so do you have any questions? If not, then we will have a short break and we will begin our session at 3 p.m. Okay, thanks for Haoliang.